on another video here on fractions. And the title of this one is that we are adding fractions with unlike denominators. So unlike denominators means different numbers on the bottom of the fraction. So if I'm going to do this first fraction here, I'm going to say that I'm going to add 3 over 8 to 5/24. So I'm going to do this, and I'm also going to model it because I'm using polypad. So I have two numbers on the bottom. They are 8 and 24. In order to do this, I need to find a common multiple. Now we say least common multiple, but I'm going to do this over to the side. And if we want to know what number to stop at, it would be 24 times 8. But in the interest of time, you're going to see you don't actually usually have to do that. So if you don't know your multiples of 8, you can take out a multiplication chart and you can look, and 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And you could keep going like that, but let's just see what we have here. Now, 24 times 1 is 24. 24 times 2 is 48. But you can see at this point that you have a common multiple. Let me highlight. You have a common multiple of 24. So that's what we're going to use. If we were going to actually model that, we've talked about doing this, modeling these. So 3/8, I'm going to go over here. I'm going to have 1/8, I'm going to have 2/8, and I'm going to have 3/8. And I'm going to move these over here and rotate them around. Put that one right there. I'll rotate that a little bit so it fits. And you can start to have a visual that 3/8 is a little bit less than a half. Now, 24ths. I don't have 24ths over here. So let's pick a number. Let's try our 8ths. So actually, let's do 12ths. If we have 1/12, I can number that as 2 24ths. That's 24ths. I could have done that with thirds. Could have taken the thirds and made it 6s, made it 9ths, made it 12ths, made it 15ths, made it 18ths, made it 21st, made it 24ths. So either of those ways I could have done that. I'm going to actually delete these. And I'm going to use these. But I only want 5 of these. 1, 2, 3, 4, 5, 6. I have 8. So I'm going to split them. And then I can, okay, let's see if that works. Yep, 1, 2, 3. So I wanted 5. 1, 2, 3, 4, 5. Oh. Let's see if I can get these all back together. I can't. Well, I'm just going to leave it like that. So I have 5 24ths here. I'm converting these are the ones I don't want. I'm converting both of these to 24ths. So I'm going to leave my 5 24ths here. And I'm going to convert my 8ths, each of my 8ths. Let's see if I can convert those to 24. So if I go 1/8, the next multiple of 8 is 16. I can break those into 16ths, and I can break those into 24ths. This 8, so if I do it times 2, that's 2 16ths. 8, okay? Or 8 times 3 would give me 24ths. And again, I'm just doing this so you can get a visual. If I actually do this math, so I want you to see how I would do it, because eventually that is what you're going to do. So I go back here. We pick a different color. I'm converting these 8ths to some number of 24ths. because that is what I got as my least common multiple. So I have to think about, what do I multiply 8 by to get to 24? I'm going to multiply it by 3. I have to do the same thing to the top. So 3 times 3 is 9. And by the way, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I use the model just to help me understand that, it is the same thing. Now I have 9 24ths here and 5 24ths here. If I put them together, I'm going to have 14 24ths. Okay, let's see, because I really would like to move these all together. Not what playing did. Okay, I really would like to group them back together, but I don't think I'm going to get to do that. So let me move them all over here. I'm going to add them together. You can start to see I'm going to have more than a half, right? Start to see that that takes up more than half a circle. So that is 14 24ths. I can also simplify that. So simplifying is finding common factors. Both of these are divisible by 2. 2 is a common factor. That might not be the greatest common factor, but I don't always have to use the greatest common factor. I can just use any common factor. So 14 divided by 2 is 7. And 24 divided by 2 is 12, which means, just see if I can do this here on this. Let's see, it won't go any smaller, but in case you're curious, you could see I could do 12s. That's an 11th. This is a 12th. 1, 2, 3. I know this moves kind of slow, but I really want you to start to be able to visually imagine the fractions. 3. Some of you are probably like, Mrs. Falk, it doesn't look like it's going to be the same. Whoa, what do I have over there? Oh, I got 6 of them over here. Okay. And 7th. So I want you to see that 7 12ths takes up the same amount of space as 14 24ths. I could rename these. Split these all to 20. Ooh, split them all to 24ths. Okay, so as we said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They are the same. I'm going to turn it back. Oh, I went the wrong way. Because I want you to see what we mean when we say simplify fractions. We just want to take that number. I know I had them all grouped together there. Take that number and get it to the smallest numbers we have. Once again, to do this, let's refresh our memories on what we had to do so we can do it. We had to find a common multiple. Okay, in this case, we found 24. We had to convert the fraction so that Denominator was the common multiple. So in this case, 3/8, we had to make it a fraction equivalent to 24ths. We did that. We showed you doing it over here, but we also did it by 8 times 3, gave us 24. So if I basically cut these 8s into 3 pieces, I had to cut these into 3 pieces. That's what actually you're doing when you're multiplying. 8 times 3 is 24. 3 times 3 is 9. We ended up then being able to add that. We got 14/24ths. And then we needed to simplify it, which is what we've done. Okay, we're going to try another problem now. So I am going to see if I can reset all this. Oh, I can. Look at that. And my next problem that we're going to do is, I got over here, 5/12 plus 3/4. So I'm being very strategic in the problems that I pick. In the next video, we'll have to convert both fractions. But in this case, I want you to kind of see that if I started making a multiples chart to find the least common multiple, 4 times 1 is 4. 4 times 2 is 8. And 4 times 3 is 12. 12 times 1 is 12. So our common multiple for both of these is 12. And as I said, I'm being strategic because one of these already has a denominator of 12. Okay? So that means I do not have to convert 5/12, but I am going to have to convert 3/4 to some number of 12ths. So how am I going to do that? 4 times 3 is what's going to get me to 12. Which means 3 times 3 is 9. So let's look at how that looks if we model it. Here's 1/12. I'm just going to copy the 2/12, 3/12, 4/12, 5/12. So I'm going to roll these up over here for us. And I always like doing it as circles because I think over time you get used to like what we call the openness or the closeness of the circle. It's 3, 4. And when you start to do this, you can also start to make some sense of the numbers. Like you'll say like, oh wow, that looks like kind of like half the circle. It's going to be a little less than half of a circle because 6/12 would be half a circle. It's going to be a little bit less. 3/4, it's going to be a little bit more. So let's start with what this originally is. This was 1/4, 2/4, 3/4. Oh, I hit play by accident. Okay, 3/4. So let's line that up. 1/4, 2/4, 3/4. And if it helps you, this times 3 actually means I'm going to break it like 3 times, if that makes sense. So if you look at this, this is the first 1/4. The second time I rename it is 2/8. The third time I rename it is 12ths. Okay? Does that see that pattern there? That's why I'm doing the same thing to the top and the bottom, because each time I break it, I would also get a different number here. So again, so that's 1. I'm doing it times 3. This is the second. This is the third. This is the first. This is the second. This is the third. So you can see that 3/4 is the same as 9/12. Okay? So now let's try and put these all so when we put them all together, I have 5/12. So I'm going to have a denominator of 12, right? But I'm adding 5 and 9. So I'm going to get 14/12. twelfths. I'm going to have something bigger than 1, greater than 1 whole circle, which makes sense because so I like these circles. I know this takes some time, but if I put these all together, there's 1/12. Oops. What did I do there? Okay. Let's move that closer together. There's, what am I doing here? What did I do? There we go. That's another 12th. That's another 12th. So that should be 12/12. Let's see. 1, let me make a note where I'm starting. I'm starting there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this whole circle is 12/12. Whoops. Which is 1 whole. And then I have 2 more 12ths, if you want to see them in order. And by the way, I don't know if this will rename. So I was trying to see, so 2/12, if I divide both of this by 2, on the top, that's 1. 12 divided by 2 is 1/6. Okay? Because this is all the same as 1/6. If you want to see that, if you don't believe me, same thing. Okay? So again, these fraction circles might be helping you. They might be confusing you. If you don't like the fraction circles, you can go back and watch the videos that are just the daily math review. The fraction action is designed to give you a visual of what these things look like. So once again, we are finding a common denominator by finding a common multiple, okay? Which means a bigger number, this helps, that they share. By bigger number, I mean larger in value. The multiples of 4 are things like 4, 8, and 12. Then, after we do that, we are converting the fractions so that they have the same denominator. And for that denominator, we're going to use the multiple that we found in our chart. Okay? Then you're going to add the top, add the numerator, which is the top. And then if you need to, let's go back over to this text box here. You're going to simplify, which also will mean an improper fraction. I said fraction should become a mixed number. It's hidden back behind there. See if I can move this. Okay, I can't move that. But hopefully that, oh, there you go. So hopefully these modelings help you. You can play with these. You can stop the video if you wanted to, but if you wanted to see these 12ths, 12/12s, it would be the same as 6/6s. See how that goes? You see how that works so nicely? So these 12ths, 2 12ths become 1/6. Okay. But we can't have our answer be like 3/6 and 6 12ths. We have to have all of our denominators be the same. And again, you can go online. You can go to you can Google polypad. It's free. You can also move your typing around, obviously. Okay, and let's do one more there. The next series of videos that I do will have us having to convert both fractions to have a common denominator, and I look forward to helping you online.